Hello, my name is Hassan. In this video, I would like to do some experiments on electricity and magnetism. In the description lines below, you can find a list of the materials and a link to the Amazon product page. In the first experiment, I will show you how electromagnets work. In the second experiment, I'm going to make a simple electric motor. In the third experiment, we are going to generate electricity using magnetic fields. And I'm also going to show you how to generate electricity using an electric motor. So electric motors can also be used as generators, and I'm going to demonstrate that. Before I do the electromagnet experiment, I would like to talk briefly about the magnets. Magnets are materials which can permanently produce magnetic fields. They have poles which are labeled as north and south. Here, the North Pole is shown as red and the South Pole is shown as the blue color. And the two North Poles repel each other. And two South Poles also repel each other. And a South Pole attracts a North Pole, and a North Pole attracts a South Pole. So you can see. Typical permanent magnets can exert forces in the order of their weights. For example, as you can see here, since the North Pole is pushing the North Pole, you can see this can levitate. If I put the other pole down, it's going to attract. But this demonstration can tell you that the force is actually in the order of the weight of this magnet. Not all the magnets are permanent, and these conventional magnets are not the only ways to produce magnetic fields. For example, you can generate magnetic fields by passing current along a wire. For example, here you see insulated copper wiring wrapped around a nail, like this one. And if you pass electricity along it, you can turn this nail into an electromagnet. For example, this nail is being attracted by any magnet like this one, but this is permanent and we are going to have the same force over and over again. But instead, if I pass current along this wire, I can turn this one into a magnet, and I can make this magnet pull this nail up. Now the current is not flowing, and there is no magnetic property here. But if I turn on the switch and let the electricity flow, then this nail would be attracted by this electromagnet. And if I stop the current by turning off the switch, this nail will most likely fall down in a second. You might need some time for it to fall down, but let's wait for it. Let's do this. Oh, it fell down. But if I try it again, there's just a very weak force remained. Yeah, but if I wait long enough, the attraction is going to vanish. So this clearly shows us that there is a relation between electricity and magnetism. There is even more to that. If you pass electricity along a wire, it is going to be pushed or pulled in the presence of an external magnetic field. This is called Lorentz Force law. And we can make use of that. Like, we can make an electric motor using this fact. And I'm going to show you how to construct an electric motor. It's a very simple one. What you need is basically a coil like this one, turn around maybe 10 times, 20 times. This is insulated, but the terminals are scraped such that they can conduct electricity. If I pass electricity along this wire and put this in the vicinity of magnetic field lines, then this is going to experience a force. And that's how I'm going to make this rotate. Here is how we can do it. Here we have a magnet which is nailed or fixed at the bottom. And we have 2 wires, which is going to serve as a cradle for this loop. So if you can see from the side view, you can see this is zigzagged so that this loop can stay there. So we have a cradle for this loop so that this can rotate freely like this. Okay. And now I'm going to pass electric current along this wire and see whether it's going to rotate. Yeah, it works. You can see that it rotates because it experiences a force exerted by the magnetic field. Okay, I need to be patient. Yeah, it works again. Good. For this demonstration, all the credits go to Faraday because he was the guy who first found this electric motor. Here I have a more sophisticated one because I have 3 coils. So this is an electric motor which was already prepared. As you can see, we have 3 coils here. But the idea is the same. We have these coils placed in the vicinity of 2 magnets. Okay, and as you can see, this can rotate freely. And when I pass current along these wires are going to experience force due to the magnetic fields, and then it's going to start to rotate. Let's see how this one works. I connect the 2 wires coming out of the motor to the 2 terminals of the 9-volt battery, and I see that it rotates. Okay, good. So this shows us another relation between electricity and magnetism. If you pass current along a wire, and if you put it in the vicinity of magnetic field lines, it experiences force. There is also another relation, which is known as the Faraday's law of induction. This law states that if you have a loop of conductor like this one, and if you change the magnetic field, for example by passing a magnet around it, then you produce electricity. This is called the Faraday's law of induction. And it's because of this law we have generators. We can convert the mechanical energy into electrical energy. Let's see how. For example, we have here a generator. It has a magnet inside and loop of coils. And if I turn the coils around the magnets, then this generates electricity. Let's see how this works. So I'm going to connect the 2 terminals of the generator to the 2 terminals of a light bulb, so that I'm going to show you the electricity is being generated, and when I turn it around, you're going to see light coming out of the light bulb. And if I turn it around slow, it's just going to glow dim, and if I turn it faster, it's going to glow lighter. This is not the end of the story. I'm going to show you one more thing, which is really interesting. Now, although you cannot see what is going on inside this thing, which is called the generator, this is also found by Faraday, I claim that it's not very different than this electric motor. Well, actually, what I'm supposing is, if I turn this wheel of the motor, it can also generate the electricity. So this is going to be a demonstration of you can use motors as generators, which is really interesting, and I'm going to do this demonstration right now. So this is the electric motor I have just used, and now I'm going to use it as a generator. I'm going to blow some air. Believe me, it's going to be really difficult. And when the wheel turns around, you're going to see that the light is going to come out of this light bulb. It's going to be a little dim. I'm sorry for that. But let me make the environment a little dimmer so that you can see the light much better. I made the room much dimmer so that I can try it now. Did you see that? I hope you saw the light bulb glowing. It was really difficult for me. This shows that although the motors are not designed for that specific purpose, you can use them as generators. So these experiments show clearly that there is an intimate relation between electricity and magnetism. In physics, there are actually two different manifestations of the same phenomena, which is called electromagnetism. I hope you enjoyed this video, and thank you very much for watching me. You can subscribe to my channel and hit the notification button if you would like to get updates about my upcoming experiments.